The matrix has eigenvalues 5 and 2 and eigenvector corresponding to eigenvalue 5 is. I am giving you or explaining you two methods. One is trial and error and second one is standard. So first I am going with trial and error. So this method is very common when we deal MCQ based type problem, and standard method student use when they perform descriptive type question, standard method. So both method is correlated. Trial and error method, actually this is not trial and error, this is comes from the definition of eigenvalue. Suppose x is an eigenvector corresponding to eigenvalue lambda. So by the definition Ax equals to lambda x. Eigenvalue is 5. So we have suggestion for x and matrix A is 3, 1, 2, 4. Now put 1 by 1 given vector. So I am randomly choosing 1, 1 as in option B. So if I use this one, so 5, 5. In left hand side I am getting 5 cross 5 and this one can be written as 5, 1, 1. So this is a vector, this is a vector and 5 is eigenvalue. So EV means eigenvalue. So this is perfect. So there is no doubt this is eigenvector. Now what is the standard method? Ax equals to lambda x. This is the definition of eigenvector corresponding to eigenvalue lambda. So a minus lambda I x equals to 0. Solve this problem. Replace lambda by 5. So a minus 5 identity x. In x you can use x1 x2 equals to 0 vector. So a minus 5 is nothing but minus 2, 2, 1 minus 1 x1 x2 equals to 0 vector of correct size. Now solve last one. So I can write minus 2 x1 plus 2 x2 equals to 0. X1 plus x2, sorry, minus x2 equals to 0. So this is homogeneous system. Solve for x1 and x2. Two equation, two unknowns. You can easily solve. So write in matrix format minus 2, 2, 1, minus 1. Now interchange first rows. Apply elementary row operation 1 minus 1 minus 2, 2. And this is equivalent matrix to 1 minus 1 0 0. So this is first pivot element. So x1 is basic variable and x2 is free variable. From this one first row x1 minus x2 equals to 0, or I can write x1 equals to x2. Our considered vector was x1 comma x1 x2, so I can write x1 x2 x1 x1. So if I take x1 as outside, so 1 1. So this is vector. This is vector and this is a scalar. So any vector having the same values means column vector having same entries 1 1. This is the only same values. Option B is confirmed.